All right, ladies and gentlemen, this is Unit 2, Presentation 4, and we will be talking about Newton's 3 laws of motion. But before we begin talking about Newton's 3 laws of motion, I want to go over some vocabulary words that I've been kind of saying throughout this unit, but I haven't really actually told you what those things are, what they mean. So I want to do that now. So the first one is acceleration. I've been using this word a lot, all right? And I want to make sure that you understand what that means. But acceleration just means that the object is changing speeds. So if something accelerates, it means that the object is speeding up, or its velocity has increased over time. Okay, I'm sure a lot of you guys have heard that. The other one is negative acceleration. Right now, this is a little bit different because some of you guys probably hear the word deceleration. But in physics terms, we actually don't use the word deceleration. You probably use it in English, but in reality, the right way to say deceleration is to say negative acceleration. Right? What that means is that the object's velocity is decreasing over time. So it's slowing down, or, and this is the big part, or the object moves in the opposite direction. Okay, so something has a negative acceleration if it, let's say if it was going right, and all of a sudden something made it move left. You now created negative acceleration in order for that to happen. Okay, so there's these two key words that we're going to be talking about. But so when I start talking, instead of saying speeding up and slowing down, I'm going to start using the words it accelerated or it negatively accelerated. All right, and then the last vocabulary word that we're going to go over is what's called inertia. And we'll talk a little bit more about this with the 3 laws. It's the idea that inertia, it's the idea that every object resists change, right? And you can actually use inertia in the use of motion or just in regular day life, right? Most objects, if not all objects, resist change. They want to keep doing what they want to do, and that's what inertia is. And we're going to talk, the inertia we're going to talk about in the sense of this unit is how that relates to motion and how things move. Okay? All right. So before we begin, I have to start with this guy right here named Sir Isaac Newton. All right, and let me just kind of clear out these annotations. All right, Sir Isaac Newton was basically he is one of the most important men of physics. All right, he is the one that this entire 3 laws of motion are named after. He basically came up and said that there's a relationship between forces and motion. And so he came up and said, after observing a bunch of different experiments and realizing that every movement, every motion that happens in this universe relates to these 3 laws. It fits within these 3 laws. So anytime you see something change speed, or you see that the motion of the object changes, or it keeps going the same, it fits within one of those 3 laws of motion. All right, and so the first law of motion that he came up with was this. And I'm going to highlight all this because all this is very, very important. And I'm going to go over what that means. Okay, so what he basically said was that, and a lot of these are pretty common sense stuff that he came up with, but he made it a lot more easier for everybody to understand. All right, so he said the first law of motion is that every object will remain at rest. So in other words, it won't be moving unless, or an object will stay moving at the same speed. So it won't be accelerating unless something forces it to move or forces it to change. So there has to be an unbalanced force. All right. Last week we talked about balanced forces and unbalanced forces. So now we're kind of moving into what does that mean? What does an unbalanced and balanced force mean? And what he said was, in order for there to be a change, you have to have unbalanced forces. Pretty reasonable, right, to understand. So one way you can use this, and I kind of gave you an example that has nothing to do with motion, but I'll give you one also in a minute. But one example of what I talk about is this. Your clothes on the floor. So if you're a messy person, right, you just throw your clothes on the floor. What he basically said was your clothes on the floor of your room will stay there unless you do something about it, unless you pick them up. It's pretty, that's pretty self-explanatory. But he said that with same thing with motion. All right, he basically said an object will continue to keep moving at the way it's moving until something does something about it. All right, and so basically what he came up with was this law, also known as the law of inertia. All right, and what that means by that is he's saying that inertia, right, the law of inertia, because what inertia means is every object resists change. And that's what the first law of motion really means, is that all objects want to resist change. And that's the reason why it's important that all objects, right, continue what they're doing until somebody does something about it. All right? And what he also figured out was that inertia, so how much something wants to resist change, depends on the mass of the object. So an object with more mass has more inertia, right? And an example I give you is this. If you pull a chair with someone sitting in it, it's going to be much more difficult than pulling an empty chair. I mean, that's pretty obvious, right? But what he said was the reason why it's more important or much harder to pull a chair with someone sitting in it is because that person in that chair has more inertia. That person in that chair resists more change than an empty chair. And that's what the first law of motion means, okay? The resistance to change. All right, and here's a good example. I give you like an animated GIF that goes with that. Let me clear the annotations here. Is this. So this skateboarder is going to keep moving, right, all the way through. So if you look at it, he is moving at this direction the whole time. So he's going this way, right? Now all of a sudden, the skateboarder hits the rock. Well, what happens to the skateboard? The skateboard, right, all of a sudden stops moving. So in the first law of motion, we can say that, hey, this object was continuing to keep going what it was doing until it hit something. So it changed. Now, why does the person then ultimately go, whee, right, the man of glass? Well, he keeps going because nothing actually hit the person, right? So what happens? The person goes flying. And I'm sure if you've ridden a bike before or if you've ridden a skateboard, this has probably happened to you, right? So the skateboard actually gets hit and it stops, but the person keeps going. And that's the law of inertia, is that the person resists change. And so therefore, he keeps going because nothing actually changed the person. The skateboard's the only thing that actually got physically changed in that one. All right, so moving forward to the next one. All right, second law of motion. So the second law of motion talks about this. And this is, again, another very, very straightforward thing. The greater the mass of the object, the greater amount of force needed to accelerate the object. Basically what that means is, hey, if the object is heavier, it's going to be harder to pull it or push it, right? You have to use more force to move that object, and so on. So if you look at the picture right here, right, this guy looks like he's trying really, really hard to pull it. Why? Because the rock is a lot heavier. It's pretty self-explanatory. While this person is like, oh, it's easy to move this thing. It's a little tiny rock. All right. So the example I gave was it takes more force to move a 50-pound rock than it does a 10-pound rock. And Sir Isaac Newton came up with that. I know it sounds silly to think that, wow, it's not very ingenious. It's pretty obvious. All right. But the thing that he came up with that was ingenious is this. It's not that this is thing, and I'm not going to really tell you guys like how to use this equation or anything like that. I just want you guys to know what this means. What he came up with was, what ingenious was this equation. He was able to quantify how much force is needed depending on how much mass that object had. It's force equals mass times acceleration. All right, that's what he's known for in this second law, is that he came up with this equation. So he was a mathematician at the same time as a philosopher or a physicist, and he came up with this. I'm not going to expect you to know this, but I just want you to know that, yes, this is a pretty obvious law of motion, but he came up with this equation. Okay? All right. And then the third law of motion that he came up with was this thing called, for every action, there is an equal and opposite reaction. And you might have heard this one before. And what basically it means is, if you push something right, there's an equal force that's going to push you left. All right? So an example right here that I have is the skateboarder guy, two skateboarders. All right? So if they push towards each other, so if they push against each other, think about this, right? If you push towards each other, which way do you actually move? You actually move away from each other. And that's what he's basically saying, is that in the world that we live in order for you to move left, you actually have to push right. All right? Think about when you walk, right? When you try to walk forward, which way do you actually push with your feet? You're actually pushing backwards. All right? If you actually want to move backwards, what do you do with your feet? You actually push forward. All right? And that kind of stuff. And that's what basically did. Like, for example, if you try to get out of your chair, right? Think about how you push with your feet. You are actually pushing your feet forward to move away from the table. And that's what he came up with and said, hey, I noticed that every single time I do something, when I have a force, I have to do the exact opposite in order to move in the opposite direction. All right? And that's what he came up with. So these are the 3 laws of motion that he observed, and he equated and had a relationship saying, hey, this is what happens with forces, and this is what happens with motion based on these things. And what I want you to understand out of these 3 things is this. These are going to be essential. For you to understand the car project, you have to know these 3 laws of motion. All right? Because the way your car is going to move is going to be dependent on these 3 laws. All right? And the other thing, too, that he mentioned about this law of motion is this. The harder that you push, again, like, for example, for these guys, the harder that they push towards each other, the faster they move away from each other. Okay? So these are just those things that I want you to think about when you're doing the car. And we'll do a couple labs that go with this that I really want you to focus on. And the more that you can understand these concepts, the better you're going to make your car. All right, when you're dealing with it. Because with your car project, you're going to be dealing with 2 things. You're going to be dealing with trying to make your car go faster, and you're going to try and make your car go as far as possible. And these 3 laws of motion that I went over just now, if you truly understand these laws of motion, you're going to be able to make your car really, really, really good for both speed and distance. Okay? And that's all I have for this. So congratulations, you're done with the notes.